I'm going to use CrystalMaker now to show you how to create a crystal structure from scratch. You might be doing this from information that you've got from the ICSD or from the literature, from a published paper and so on. But you'll need to know in advance the space group, the lattice parameters and the atomic positions as well. So I'm going to use the example of sodium chloride. So to create a new crystal, first of all, I will go to the File menu and then click New and Crystal. And that opens up this new crystal sub-window. First of all, we need to put in the space group. The space group for sodium chloride rock salt is FM bar 3M. So we would enter that as FM bar 3M. So you can see that I've left a space in between each of the operators in the space group notation here. And that's really important. If you're not sure about the notation, you can click the Browse button and navigate through. So I know that the symmetry is cubic, I know that it's F-centered, and I could scroll through the list to find FM bar 3M. Similarly, if I was looking for something tetragonal, I could look at tetragonal, body-centered, and find the space group in that way as well. But we want cubic FM bar 3M there. Okay, so I'm going to close that. Next, we put in the lattice parameters. You'll see it's only given me one option here because it recognizes that it's cubic. So it knows that the angles are all 90 degrees and that A equals B equals C. So I'm going to put in the lattice parameter, which is 5.6573 angstroms. Next, I'm going to add in the atom positions. We don't need to put in the position of every atom, obviously that would be crazy. All we need is one particular, what's called a Wyckoff position for each atom position. So in sodium chloride, there are two basic atom positions. So I'm going to add in two sites here. And you can see the default label T1, T2, and it always defaults in CrystalMaker to having silicon. Obviously we need to change that. So our first atom we'll put in the sodium. So I'll put in the label as sodium. And the occupancy, well, the sodium site is filled with sodium. So I'm going to put in sodium there. We could put in partial occupancies. So if we were looking at something that had more than one atom on the same site, we could put that in so it's a fraction after the atom name. But in this case, sodium chloride is just sodium that's on the sodium sites. So we can just leave it as Na. Fortunately, the sodium is on 0, 0, 0. So we can leave that. And then we can put in the chlorine. So again, I'll call it the label of chlorine. Occupancy Cl. So all chlorine on the chlorine site. And there we go. We can then need to put in the atom positions for the chlorine, which will be 0.500. From the space group, it can then generate all the other atoms in the unit cell and beyond, in neighbouring unit cells, just using this information. Don't worry about these U values at the end here. These refer to thermal parameters, a measure of how much vibration there is in the atomic site. And this is the sort of information we might have if we've been doing a Rietveld refinement to solve a crystal structure. But to draw a crystal structure, we can leave these blank altogether. I'm now going to press OK to accept that. I'm finished here. OK. And you can see the crystal structure that's been drawn on the screen here. Not ideal because it's used the same colour, more or less, for the atoms. And so we're going to want to change that straight away. What we might do is go up here into the site browser and then click on the colour, and I might just go for sort of quick easy blue for the chlorines and a nice red for the sodiums. Okay, so that looks a bit more like it. The background being black is not ideal, especially if we want to put this into any sort of report. We're going to want to change that. So we can do that in the model inspector up here. Go into the background tab, and then we can change that to be white, for example. So that's a bit more ink friendly if you're going to try and print this out later. While we're in the model inspector, we should also look to change the unit cell display. At the moment, the unit cell isn't displayed on here at all. So we can go over to the unit cell and surface tab here and tick on the unit cell frame. And so you can see that there, it's in white. So I'm going to change that so we can actually see it. So there it is in black, much better. We could change the thickness of those lines as well if we wanted, but I tend to prefer them quite thin. I'll close that for now. At the moment, we haven't got any bonds on here. We don't know anything about how the atoms are really coordinated, and bonding would certainly help with displaying that information. So to change that, we can go to the model menu. We can see we're in ball and stick mode at the moment. There's nothing on. Okay. So what we'll do is go to edit and then bonding. And you can see the reason it's not showing us any bonds is because there's no bonds being set by default. So we're going to need to add in a bond. So click the plus symbol down here, and you can see it's offering us to add in chlorine-chlorine bonds, which wouldn't make a great deal of sense. So let's change this from chlorine to sodium. So we've now got bonds from the sodiums to the chlorines. It puts on a default bond length maximum, which tends to be quite realistic, but always check the coordination here. So we can see that the sodium is going to be coordinated by 6 chlorines, the chlorine by 6 sodiums. It's always worth checking the literature. Is that reasonable? We know for sodium chloride that it is, so we can accept that and say okay. If it wasn't and we weren't sure, we could just increase that Bmax a bit and see what happens. But we're happy with this, so press OK. And there you go. So now it's got the balls and sticks. One thing we might like to do is display the crystal structure in terms of polyhedra rather than balls and sticks. So let's go back to model and click onto polyhedral. And now you can see it's lost the balls and sticks, but it hasn't actually shown us any polyhedra either. The reason for that will be hidden in the model inspector. So go back into that again. And then on the first tab, atoms, we can see that the atoms here are both set to display as spheres, which is what we're seeing in the main display. So what we're going to want to do is change one of these. I'm going to pick the chlorine and then display it as a polyhedron. Now, could use rendered solids, you could use plain and so on. Stripe filled can be quite useful for publications where you might not have colour, but I tend to prefer, as my first choice, the translucent polyhedra plus sphere plus bonds, so it shows you everything. So let's go ahead and select that. And now we can see we've got one single polyhedra, which is nice. Doesn't really tell us a great deal though. So what we might do, we might want to expand the range of this so that we can see a bit more. And so to do that, all we would do is go into the transform menu and click set range. I also have this shortcut on my window toolbar here where I can go in and set range there. And then we can just expand until we're satisfied. It's a good idea to tick on the live update, and then it will update the display as we go. And so I'm going to click expand, keep going, and then all of a sudden you have a lot more polyhedra being displayed. Obviously now this is too big for the display, so I'm going to click auto center and auto scale so that it now fits onto my display. And you can see we've got a lot of additional atoms around the outside of our crystal structure, around the outside of our polyhedra. So we might use the lasso tool to go ahead and remove some of these excess atoms. So lasso them to select them, then right click and hide selection. And so that can be a really powerful way of improving the display. Obviously you'll never get them all in one go, so you have to go back and then select from a different orientation the ones that you can now see as well. And right click and hide selection. And you could keep going until it all looks nice and tidy. So the polyhedral view is really useful when you are looking at structures that are layered or quite complex, but it's not so useful when you're looking at a crystal structure like the RockSalt structure, where everything is very densely packed. Obviously, now that we've put on several polyhedra, we can't actually see the unit cell anymore. We can't see into the unit cell. We're actually masking a lot of the information that we're trying to see by having crystal structure visualization. So that's not ideal. So in this case, I might actually just undo the hiding of the atoms that I've done. I can do that easily on a Mac because I can just press Command Z. There'll be similar commands from the edit menu on Windows. And then once I'm happy, I could just go back to balls and sticks, which actually, one might argue, is a more meaningful view. Here we can see we've got a number of unit cells. We might not want that. We might change the scaling again over in plot range, but we can easily see the crystal structure now. much better balls and sticks and polyhedra for the sort of alkali halide rock salt type things. So the final thing I'll show you is we might put on some depth fading. So this is the End tab in the model inspector here. And so we can start to mask or fade out some of the atoms at the back. We can change the perspective here as well. So we can change dramatically how things look. So be careful with that. But also we can change how severe the depth fading is. Depth fading can be really useful, but obviously you are hiding information, so be careful not to overdo it. It's certainly not something I would do if I was only looking at one unit cell. But if you're looking at many unit cells, it can be useful just to hide some of the overload, if you like. Okay, so once you're happy, you want to get this out. I'm going to just change the view back a little bit. So I might go to look down the 100, and then usually I'll offset slightly from that. So maybe 5 degrees down, 5 degrees to one side, so that you get more information about the depth. And then once I'm happy, I'll go into the file menu. I might save my work so that I can load it up again in the future. And then I might also go and export a graphics file so that I can paste that straight into Word or PowerPoint and so on. So hopefully that's been a useful exercise for you and you've learned a bit about how to use CrystalMaker in a real example.